Welcome to the second episode of AI Mastery Series in Unity C#. If you missed the first video, definitely check it out as it lays the groundwork for what we're building on today. We will learn how to move NPCs in groups with various formations. This is great for many gameplay scenarios. For example, you could have a group of bodyguards surround a VIP as they go through dangerous territory. You could make a military convoy that you could ambush as the player, or a horde of mindless zombies roaming through an abandoned city. For the purposes of this tutorial, we need a bigger scene, so I made it bigger to accommodate our group's moving in formations. Before diving into the tutorial, there are some issues about NavMesh generation that you should be aware of. If your level has obstacles or walls in a concave shape like this, the NavMesh may generate underneath it. If we're somewhere around here and we use navmesh.samplePosition, it may give us a position inside of this obstacle. And in fact, with our previous code, you can see that some NPCs are spawning inside of these obstacles, which makes it impossible for them to leave. To fix this issue, we can either add a NavMesh obstacle script to this obstacle, check carve. So the problem here is that the NavMesh obstacle only has a box or capsule shape. For our concave obstacle here, this will not work. What you can do is to break down this obstacle into smaller boxes. Or there is a second solution. We can modify our ground plane and remove the faces underneath this obstacle. This approach, however, is destructive. So we'll simply change the shape of our obstacle for now. Let's bake the NavMesh again. Now you can see that the NavMesh obstacle is properly carving the NavMesh, and there is no NavMesh underneath it. You may also have noticed that NPCs are walking above the surface a little bit. To fix this in your NavMesh surface, you have to check Build Height Mesh in the advanced options, then bake your NavMesh. This should fix the problem, and NPCs now will be properly walking on the ground. I also made our areas bigger. So here we have area 1 with a radius of 57 and area 2 also with a radius of 57. We want to be able to toggle our wander behavior on and off. So in our NPC script, let's add a wander boolean. I'm also adding a selection base attribute, which makes it more convenient to select NPCs in the scene view. So when you click on an NPC, it will select the root object directly, rather than selecting the skinned mesh or part of the skeleton. Let's also add an alive boolean to determine whether the NPC is alive or dead. Let's also add a direction. This is the direction of movement, which will be very useful later on, and I'll explain why. This direction is a vector tree. We'll be able to get it publicly, but only set it privately. And by default, it will be set to vector_tree.forward. Let's also add a convenient property for accessing the position of the NPC. In the update method, if current speed is not 0, we'll update the direction and set it to the agent's velocity normalized. We'll also need a reference to the group the NPC belongs to, but more on that later. In our NPC Wander script, let's check if Wander is set to true before doing anything. So we'll add an if statement in the start method and another if statement in the update method. So if NPC.wander is set to false, we'll simply return. Now if you want your NPC prefab to work as it did before, go into the NPC script and make sure wander is checked. I'm using two NPC prefabs, a guard leader and a guard follower. So the only difference between these and the NPC prefab we created before is only a cosmetic difference. So I've given them a rifle. I'm using one of my models. It's the Artemis Militia Tactical Assault Rifle that you can find on the Unity Asset Store. As for the animation, I'm using Rifle Idle from Mixamo. When you download an animation from Mixamo, make sure the format is set to FBX for Unity, and set the frame per second to 60. And in the Unity editor, make sure the animation type in your rig is set to humanoid. Otherwise, it will not work. To make the characters carry the rifle, I parented the rifle to the right hand here in the hierarchy. Go into local mode here, Then change the local position and rotation until you have something satisfactory. I created a new animator for these NPC prefabs with a new animation layer. In this layer, we have the rifle idle animation, and we use a upper body mask. The upper body mask disables the lower part of the body. So the rifle idle animation will animate the upper body. And the base layer is the same thing that we had before. We have our blend tree here. And for the leader, I made a military hat in Blender, and I parented it to the head bone of the character. Now let's explore how to create groups and how these groups can move together using a formation. In our scene, we have a group manager, which is a simple empty object with a group manager script. So this script will have a list of groups, and in the group script, we have a list of members and a reference to the formation that they use. For the formation, we're using a scriptable object, which is very convenient. We can simply change the value here, and the group will use that new formation. And in our NPC prefabs, we add a guard AI child object, which has a NPC Group Member script. Now let's see how these scripts work. This is the group manager. Very simple. It has a list of groups. We have the create group method, which creates a new game object for the group. It sets its parent to the group manager, then adds the group component, and in the end adds this group to the list of groups. For convenience, I added a context menu attribute to this, which allows us to create a group in the editor through this menu. Create group. Here it has created group 2, has parented it to the group manager, and has added it to the list of groups here. So this is just for convenience if you don't want to do it manually. Then let's explore the group script. In the group script, we have a list of members. This is a private list, so to access it, we add a public property. So how the list of members work is that the first item in the list is the leader, and the other ones are the followers. Here we have some useful properties and methods. Member count, follower count, which is member count -1, so minus the leader. Get follower index, which returns the index of an NPC -1. A method to check if an NPC is the leader. Get leader returns the first member. Then we have get position in group, which uses the formation and returns the position of the NPC. We'll see this shortly. In the start method, we initialize all members by setting the group property to this object. Remember that we defined the group property in NPC. And in the update method, we remove dead members from the list of members. If you want to go through a list or an array and at the same time possibly remove some elements, you have to navigate the list in a reverse order starting from the last element to the first element. If the member is dead, then we remove it by setting its group to null and then removing it from the list. And finally here, we have two methods that other scripts can use to add a member or remove a member. So adding a member, we simply add it to the list and set its group to this object. And for remove member, we remove it from the list and set its group to null. In order to visualize this group in the editor, we use onDraw gizmos. So if our formation is null, or member count is 0, or the draw gizmos boolean is set to false, we do nothing. Here for each member, we get its position in the group. We draw a red sphere for the leader and a green sphere for the followers. Formation is a scriptable object. It's also abstract. Formation has an abstract method called getPosition, which returns a vector tree and takes the NPC and the group as parameters. And here I've added a method called adjustPosition, which takes the position of the NPC and the leader position and returns a vector tree. This method will be useful to all child classes of formation. That's why I added it here, and we'll see what it does shortly. Before we dive into the specifics of formations, you should know that if you run the game now, nothing will happen because all we did so far was create a group manager and a group. When the game starts, the group attribute of our NPCs will be set, but other than that, nothing will happen. That's because we need a script that controls the behavior of our NPCs and will be included in a game object that is a child of our NPC object. So here I have my guard leader with a guard AI object that I created. Here I attach an NPC Group Member script. What's great about this way of doing things is we can have these objects as prefabs. So for example, I can have guard AI as a prefab, and at runtime, when I create my NPC, I can simply add a guard AI child object to it. And we can create different objects for different kinds of NPCs. So for example, you can have a VIP, a bodyguard, a zombie, a soldier, anything you want. And it's completely modular. So if this object didn't exist, our NPC will work just fine. So let's explore what NPC Group Member does. So as we said, NPC Group Member inherits from NPC Component. And as a reminder, NPC Component simply has a reference to NPC, and it gets this reference in the wake method. In the update method of NPC Group Member, we'll check if we don't have a group, then we will enable the Wander behavior and return. If we do have a group and NPC is the leader, then we'll set NPC Wander to true. If we're not the leader, we'll get the position with npc.group.getPositionInGroup. We'll set the agent's destination to that position, and we'll set the stopped property to false, and we'll disable the wander behavior. Let's go back to our formation script. So this script defines a contract, which is this method getPosition, and the child classes will implement this method differently depending on their type. Let's create a column formation. In each child class of formation, let's add a create asset menu attribute to allow us to actually create that scriptable object in our project. Let's implement the getPosition method. If the NPC is the leader, we simply return the position of the NPC. Otherwise, we get a reference to the leader. The position of the NPC in the group will be computed from the position of the leader minus the direction multiplied by spacing and the index of the NPC. In other words, the followers will be in a line behind the leader. Let's visualize the column formation. So I'm going to right click. Here I created a data folder with a formations subfolder. I'm going to right click, go to create game formations. And here I have all the formations I've defined. So I have a column, circle, line, and convoy. For now, we've just seen the column formation. So I'm going to click on it. So it creates a scriptable object. I already have a column formation here, so I'm going to use it. So let's go to our group 1. And here let's set the formation to our column formation. And let's enable draw gizmos. So here you can see that the position of the leader is marked by the red sphere and the position of the followers are marked by the green sphere. So here I'm still in edit time, by the way. I'm going to move the leader. Here, if we were to just return the position, let's say return position. So here we can have this scenario where the positions are inside of obstacles. In our case, this is just a wall, but you can imagine that this whole area is an enemy base or somewhere far from the position of the leader. So what this means is that the followers may go a long way before reaching these positions. So we need to process these positions and actually use a NavMesh raycast in order for the green spheres to always have visibility over the leader. So we use the adjust position method that we've defined in the formation script. Let's uncomment this and let's remove this. Okay, let's go to our formation script. So what adjust position does is we give it the position of the NPC and the position of the leader, and it does a raycast from the position of the leader to our current position, and it outputs a NavMesh hit. In case it hits an obstacle, we return the hit.position, and in the other case, we return position. So when there is an obstacle between the follower and the leader, the formation will compress like so. This solution is not perfect, but it will make sure that at least the NPCs do not get very far from the leader when they try to reach their position in the formation. I said I was going to explain why we use the direction of movement. So here in the code, we use leader.direction. Here we could simply use the the leader forward vector. However, what this means is that every time the leader changes the rotation, the whole formation will change, and we don't want that. So if the leader doesn't move, we don't want the whole formation to move. That's why we use the direction of movement as we defined it in the NPC script. With the line formation, the followers will form a line behind the leader. As we did for the column formation, we'll use a spacing variable to determine the space between the followers. We'll use the same variable to determine the spacing between the leader and the line. In blue, we represent the direction of movement. We'll also need a right direction. In the code, we'll compute the position of the leftmost follower, represented here by the letter A. Then we can compute the position of each follower using A plus spacing multiplied by right multiplied by the follower index. The A position is minus direction multiplied by spacing. So from the position of the leader, we need to go back by this much, and then we need to go left, and this distance will be half the width of the formation. So the width of the formation will be spacing multiplied by the number of followers minus 1. Okay, so let's put this in practice. Here we have the line formation script. First, we need to compute the right direction. We use a cross product between vector 3 up and leader direction. Then the position of the follower is computed as the leader's position minus the direction multiplied by spacing. Then we need to compute the formation width, which is the follower count minus 1 multiplied by spacing. We subtract leader right multiplied by half of the formation width. So basically at this point, we are at the A position, which is the position of the leftmost follower. Then we add the right vector multiplied by spacing and multiplied by the follower index. Then we return the adjusted position. Let's visualize this in the editor. So here I've created my line formation. Let's simply set this as the formation of group 1. So here I can change the spacing of the line. So perhaps we need two variables, one for the distance between the leader and the line, and another one for the spacing between the followers. But I'm going to keep it like this for now. So the leader wanders around while the followers try to reach their positions in the formation. So if the leader is close to a wall, the formation will compress. So this is not a really big issue. So the biggest issue is what we covered before. Having NPCs go all the way around your level to reach their position, that is really bad. But this solution is quite decent. To make a circle formation, we divide the circle by the number of followers. So we compute an angle, which is 360 divided by the follower count, and we multiply it by the index of the follower. And the position will be the leader's position plus a rotation around the y-axis by angle multiplied by the leader's direction multiplied by a radius variable that we define here. Right now we have 4 followers, so they'll just be in a square around the leader. Let's add more followers. So I'm going to duplicate a couple of guards. Let's add them to the group. With 6 followers, you can see the circle more clearly. Remember that we set selection base on our NPC, so when I click on an NPC, the root object will be selected. This is very handy if you want to quickly select your NPCs. So this also will be a great opportunity to test the alive boolean. Let's click on this guy. When we run the game, at some point we'll set the alive boolean to false, and we'll see how the group removes this NPC from the formation. This NPC, being not part of a group anymore, will switch to the wander behavior. Here we'll just make sure that area is not null, because that will create problems. Our NPC is moving into formation, so let's make this character dead. So you see how the NPC has been kicked out of the group and the group has reformed, and now this NPC is wandering around on its own, not part of the group. In the convoy formation, each member will follow the member in front of them. That member will be the leader in this case. So if the distance between the member and its leader is greater than a value, they will move towards the leader. And if it's lower than that value, they will stop. we'll compute the direction from the leader to the follower, and we'll multiply it by the spacing value, and this will be the position returned by the formation. So let's write a Convoy Formation script. Let's use a spacing variable. So you can argue that we've been using spacing for almost all our formations, so we might as well add it to the formation base class, but that's up to you. That's a personal preference. This if statement is repeated across all formations, so maybe we can remove it from here and add it somewhere else. I'll leave that up to you. Here I'm getting my member index. The leader of this NPC will be the member at member index -1. Here we compute the distance to the leader. If the distance is inferior to spacing, we return npc.position. Otherwise, we'll compute this is actually wrong. We need to do the opposite. So we need to compute npc minus leader position. And the target position will be computed from the leader's position, not from the NPC's position. Let's call this direction. So the direction will be the direction from the leader to the NPC's position. Then the target position will be the leader's position plus direction multiplied by spacing. Then we adjust the position and return it. To demonstrate the convoy behavior, I'm going to take control of the NPC leader. I'm going to simply disable the NavMesh agent and move it in the scene view. Here you can see that each group member follows the member in front of them. This is a more flexible formation compared to the line. In the last part of the last video, we created an NPC generator that spawns a number of NPCs in an area. We'll do the same thing for groups. We'll create a group generator. We'll give it a list of formations, a list of areas, and the prefabs of both the NPC leader and the NPC follower. We'll define the mean and max group size and the number of groups it will generate. The group creator will require a reference to the group manager, so we add a requirement for the group manager component. These are the variables that you saw in the inspector and the reference to the group manager. So in the start method, we get a reference to the group manager, and then we create the groups. The method createRandomGroup will call groupManager.createGroup. It will pick a random area from the list. So here I have two utility methods to get a random area in the random formation. We get the leader's position using area.getRandomPoint, and the leader's rotation will be random as well. We instantiate the NPC leader prefab, and we set the area on the NPC Wander behavior to our chosen area. Then we add the leader to the group, and we set the formation of the group as well. Here we get a follower count using random range, and in a for loop, we create our followers. The way we create followers is we instantiate the NPC follower prefab, we add the follower to the group, and then we're going to use group get position in group to compute the position of the member, and then we set follower.transform.position to this member position. By this, we've reached the end of this tutorial. Thank you for watching and see you later.